In the name of God. Hello. Greetings to all viewers. I'm Parandvar. I have a PhD in Economic Geology and Mining Engineering Exploration Orientation from Iran. In this video, I will teach you how to draw topographic profiles and then draw geological features including geological units, faults, intrusive veins, rivers, and etc. I would be very happy if you would join me. This training is very useful for geology students. Thank you for supporting the video by liking, commenting, and subscribing. In this video, we will learn how to draw geological profiles and how to make them. First, we have a geological map containing geological units, faults, mineral veins, streams, etc., from which we want to consider a cross-section to create a geological profile. You need a DEM map to make it. DEM, Digital Elevation Model. You can download these maps from the American Geology website. Or for a smaller scales, use topographic maps prepared by surveyors, cutting it with the bounding card using the clip command. You can download the maps in different scales from the www.earthexplorer.com. Turn off other layers you don't need. Consider have a profile with a northeast-southwest trend. The length of the profile is approximately 620 meters. First, activate the 3D Analyst toolbar in ArcMap. Through the Customize option, make sure that this item is checked in the Toolbar section. Use the Interpolate Line option in the 3D Analyst toolbar. Hit it when you need it. Always draw sections from left to right like the Cartesian diagram. Do the command left-click twist at the end of the drawing. A graphic rectangle is created, which is the basis of starting work. Enter the toolbar of 3D Analyst, click on it, and select Options, a window named 3D, Analyze option will open. Enter the Graph Data tab. Click on the menu and location to save profile graph data. Give the appreciate name and pass only, then click OK. For example, PG underline G. Do not enter the folder itself. Then click OK in the window. Tap the Profile Options, Graph Options. Throughout the section, the dam scale is very important here. The topography is very rough. "12 centimeters scale is used here. Right click on the Profile Graph title window. Click the Export option and select the JPG option. Set the quality to 100. Then click the Save option. Give a suitable name and pass. Here and save it. Then click the Close option. You have georeferencing to make the created image. Close the window. Enter the created image through Add Data. Click on Zoom to Layer. You must draw this section in the Cartesian system. Enter the georeferencing toolbar. Remove the Auto Adjust option and be sure to pay attention to which place the image you want to georeference in front of the ribbon. Here is the picture with the name Section G Profile Graph. Click the Add Control Points option. Try to transfer coordinates from left to right in a rectangular manner. click the first point, then right click and select Input X and Y option. Enter the X, Y and Y value relative to the point you clicked. Have the value of X0 and the value of Y is 1100. Click the OK. For the second point, move up parallel to the Y line and click on the point X is equal to 1220. Select the Input X and Y option, enter the X and Y values and click OK. Move a little to the right. Here draw vertical graphic lines as auxiliary line. Click on the point X is equal to 600 and Y is equal to 1002. Select the Input X and Y option, enter the X and Y values and click OK. For auxiliary points are enough. X is equal to 600 and Y is equal to 1100. Then OK. Click the Auto Adjust option from the georeferencing toolbar. In the OTC, right-click on the JPEG and select Zoom to Layer. In this case, you can see the profile is its place. You can also see the auxiliary points, which can be seen green and red colors. In the fact, move the point with the wrong coordinate to the corrected point. Now rectify the photo. Save the section in the corresponding folder in TIFF format. Then wait. From the Add Data option, enter the TIFF format. Delete the previous JPG image. Try to always remove extra layers in the OTC. The section is in place. The next step is to create the shape of the coordinate axis. For this, you need two layers, a point layer and a line layer. Naming the shape should be clear. First, create a linear layer and name it like this: axis section. Make the shape type to linear. Then click Edit. Enter the UTM system zooming number according to the section position. You must have determined this zooming in advance and extracted it from geological maps. Then click OK. Make another shape again. Create a point layer. Make the naming like it. Click Edit, select the coordinate system, then click OK. In this way, the coordinate points that are to be drawn on the coordinate axis are made. Try to save the project regularly so that if the system is interrupted for any reason, the project will not be lost. In the linear mode, you must specify X and Y positions with the absolute option. First, start drawing the linear layer and then make the point layer. Right-click on the linear layer and select Edit Features and start editing. The Edit toolbar is activated in the Create Feature window. Click on the linear layer, right-click on the screen and select Absolute X, Y. Type X as 0 and Y as 1100. Click OK. The point is placed in the actual location on the map. You should take the coordinate a little lower than the graph axis. Click the Undo option. Press the absolute XY again. Note that the vertical axis is marked in terms of 20 meters. Type X as 0 and Y as 1080. Click OK. You should draw the vertical line upward. At the end, the line 1020 is written if you pay attention to the tip of the diagram. It seems to be a bit higher than this number. Consider 20 units higher than this number. Click the absolute option, type X and 0 and Y as 1240, click Enter. This is how the vertical line is drawn. Return to the first position. What does it mean? Click absolute option. X is 0 and Y is 180. Now you have to move the right. Check X to see how many meters it has been placed. About 650 have been placed, or maybe better, 650 have been placed, or maybe better, 630. Type X as 130 and Y as 1080. Click Enter. Draw another axis parallel to the first vertical line. Click absolute option, type X as 630, Y as 1240, right click and select Finish Sketch. The chart is created. From the edit to click Save and then stop. Next, create points on the graph. For this work, click on the option Axis Points section G. Right click and check Editor Features, then click Start Editing. Enter the Create Features section and click on the Axis Points section G. Make sure Snap and Option are turned on. Right click at the top of the software. Click the snapping option. If the points are blue, they are on the line. If you place the point on the point on the line with the mouse, it is placed on it by gravity. We start from 0. Click on it for the next point. Click X, Y, X equals 0 and Y equals 1000 and 100. Click again and select absolute X equals 0 and Y equals 1120. Similarly, specify the height on the axis. X equals 0 and Y equals 1140 is X equals 0 and Y equal 1160, and the X equals 0 and Y equals 1180. X equals 0 and Y equals 1200. X equals 0 and Y equals 1220. For the last point, use the gravity of the snapping. Place the mouse cursor on the horizontal line. Helps you set coordinates faster. Right click and choose the absolute XY option. Y, it is a fixed number of 1180. Just enter X. Enter the points in the same way. X. Enter up to 600. Then editor click. Click Save Edits and click Stop Editing. Now the graph profile is in place. Turn it off in the TOC window. It seems like 3 points of error have been made. We will correct them again. Click on the point layer symbol. Choose a standard symbol. Choose cross 1. Resize it, give it the right color. Now we need to enter the height and area numbers on the horizontal and vertical axis. Click on axis points, open it at attribute table. We need to add to column. To it, click add. Field 1 column is for the X coordinate. In the type option, select double. Click OK. Drag the column to make it small and fit. Create column Y in the small and fit. Create column Y in the same way. Left click on the X column header and then right click. Select the calculate geometry option. Click OK. Enters the X coordinates. Column Y is the same in the property section. Set Y coordinates of point. Click OK. Thus, for every X that was created, it also specifies similar heights. For example, created for X equals 100, 8 is 100, its height is 1080. Remove extra column. Close the table window. Now we need to the label. Right click on the point layer. Go to the Tables tab and choose the second option. Check the Label Features option. Click the Add option and define it once with X and once with Y. Also clear the default option. Click SQL query. Determine the values of X that be greater than 0. Click OK. Set the label field option to X. Use a standard font. For example, Times New Roman font. Set the font to the appropriate number. Check the expression option to that it is on the desired axis. Click Placement Properties option. Go to the Placement tab. Click Change Location. You should place the X value on the coordinate axis at the bottom of the axis and the value to the left of the axis. Click Prefer Top Center. Allow it. Click OK. The number is high and needs to be corrected. Go to the Placement tab. Click Prefer Bottom Center. Allow it. Click OK. The number is well placed blue. The x-axis numbers are correctly specified. Repeat the same for the y-axis. Set the class to y. Click SQL query. The value must be greater than 0. Set the label field to y. Set the expression to y. Choose the right font. Click Placement Properties. Then click Change Location. Click Prefer Center Left, then click OK. By zooming in, you can see the numbers are their proper place. It should be revised again, and y values greater than 1080 should be selected. Set the class to y. Click SQL query. Y values greater than 1080. Expression in the same way. Click OK. This way you get a standard chart. Be sure to save the project. In the R catalog, drag the PG2 shapefile into the TOC. Click OK. If the layer is not displayed, click the refresh option on the top of the folder. Now you need to convert the point layer to a line. Open the layer table. Contains column M and Z. Delete the ID column. Turn off the FID and shape columns. Click Select All option. All rows are selected. Right click on one of the rows. Choose Copy Selected. Enter the system desktop. Create a text file. Give a suitable name. Click Ctrl. In addition to paste here in the first row, type the number 0 under column M with 2 decimal places. Click the Save. Place this text in the path. Give a suitable name. Log into the software, enter our catalog, and find that text file. Refresh the folder on the main folder. Right click on the text file. Click Create Future Class. Click from XY table. Put X field on M and Y field on Z. Put field unknown. Z put field unknown. Give the appropriate name and pass from the output option. Wait for the software process to finish. A pawn shapefile is created. Enter it. Now the topography layer has been created. Remove excess layers. Zoom in on it. Some parts are not yet connected to the diagram. It was the same number 630 that you entered. We need to fix it. Click Edit on the Axis Linear layer. Click Move option. You have to place the dots in their places. Click on the last point on the chart. Look at its coordinates. Do this with the Identify option. Copy it. Modify the diagram in this way. Right click on the Y chart at the top and clip enter the value of X. Click the Save option and save the project. Standard chart is the mate. Click the Search option. Self-forge the phrase point to line. Click Points to line related to data. Click Points to Line Management. A window of the same name opens in the Input Features section. A point layer is created. In the next section, give it an appropriate name and pause. Then click OK. Now the points become lines. Turn off the top chart layer. remove excess layers, give the line layer the right color. This is how the topographic surface is created. And be sure to try to make the trend line consistent with the Cartesian graph. Now on this surface you need to draw geological layers, faults, alterations, waterways, etc. Thank you very much for watching the video. In the next section, we will teach you how to draw a geological profile, including geological units, faults, streams, mineral index, and everything on a geological map that you can use to create a profile.